this is what already I discussed. Once again, I'll put it in order. Huh? So this will be induced charge. So there's a isolated charged capacitor. I'm going to bring a dielectric slab. Right, I have to give a condition. No? This condition is very important. Even in SU Verma, he has discussed this. So this is the minus Q plus Q. So what is the force of interaction? That is F. Force exerted by one plate on the other plate. Now what is this formula? Q square by 2A epsilon naught. Now, after bringing slab, what will happen to force of interaction? So let me take the surfaces. Within the method what we used. So I'm going to, so what are the charges here? Negative charge will be induced. Positive charge will be induced on this. So here there's a positive charge. So the surfaces will be 1, 2, 3, and 4. So the charge present on surface 1 will experience force due to 2, 3, and 4. That's the only idea. The methodology you have to think like this, because so all these charges are there. So we know Qi? Okay, how to bring Qi? Q into 1 minus 1 by K. That epsilon R is what? I'll write it as K, that one. The induced charge on the slab is given by this formula. Is it okay, this one? This also better. Say, don't derive, you can't derive everything in exams. At least some memory should be there. Here, so you can save in exam. Otherwise, again, deriving this induced charge on the slab, it will take another 2 minutes. Finish or no? So there are standard things are there where if you remember, you'll be on safer side. Okay, now we know Qi. Okay, the force acting on the charge present. So I'll directly go for, let me write only F1 like this. This F1, what shall I write? What is the charge present there? Q. It will, how the field, this will produce field in what direction? Will be like this, no? This will produce field like this. And this will produce field in this direction. E4, E3, E3, E2, and E2. The resultant of all this has to be taken. So in what direction the E2 will be? Towards right. In what direction due to charge on surface 2 will be towards right? Due to 3 it will be opposite. So therefore this should be equal to E2 I cap minus E3 I cap minus E4 I cap. So okay, we'll do one thing. Negative, no, it should be. So E4 plus E4 I cap it will be. Look at the directions. Okay, fine. Okay, now write this one. What is E2? E2 should be equal to sigma I by 2 epsilon naught minus E3 should also be sigma I by 2 epsilon naught. This should be equal to sigma by 2 epsilon naught. All together, let this be I cap. Sigma I, can we write anything sigma I again here? Sigma I should be equal to sigma into 1 minus 1 by K. These two will cancel out. So no need to simplify. Huh? These two will cancel out. So only it will be there. So how much it is? Q by sigma 2 epsilon naught I cap. What is the intern sigma Q by A? Look at the force. Earlier it was F, no, now it is F1. So therefore F1 equal to F. So what happened to force of interaction? See, this question is there in SC Verma. Am I right? Everyone objective question is there. How many of you really draw diagram and analyze? So I've seen 90% of students, even in SC Verma also, there is a necessity to draw diagram to analyze. They're the questions, not like something which has to be remembered. If you are not given diagram, doesn't mean that you should not draw diagram. That's not like that, no. The analysis, you see, that's what in exam, no, you analyze like this. You go back to the basics, analyze, and conclude. So if you bring, there is a force of interaction acting between the plates, force of attraction. If you put a dielectric slab, what will happen to that force of interaction? Will not change. Agree this? So what happened to charge? Charge will not change. If charge doesn't changes, capacitance will change. So potential difference, will it change? V equal to Q by C. Q constant. C changes. V changes. If V changes, E will change. Yes. So some set of questions are there. Please do analyze. Okay, this is about the, so what is the conclusion? So I think at least you remember this data. The force of interaction between the plates of capacitor will not change on introduction of slab. Force of interaction between the plates of capacitor change on insertion of slab in the capacitor. This is a conclusion. Okay, now if I think this I did, the next part I don't know, something it got missed it. There was no conclusion for next part. One more condition is there.